How do you go from this to this? Only using basic trigonometry. Okay, I lied. We're going to use a little bit of physics too. Let's see it. So it's a regular pentagon inscribed inside the unit circle. You can work out that these angles are going to be 72, and then this guy gets cut exactly in half. Now you'll notice that 36 and 72 are showing up, and I've got sines and cosines just labeling the points on the unit circle. Where does the physics come in? Well, if we think about 5 people pulling in all of these orange directions, because of the symmetry here, everything is going to cancel out. There's not going to be any movement left, right, up, or down. If you think about the contribution in the x direction, you have 3 people pulling to the right with coordinates 1, cosine 72, and cosine 72, and then 2 people pulling to the left. When you write this down as an equation, it must mean that twice the cosine of 72 is this expression over here. But you might remember the double angle formula from trigonometry. That's the only thing we'll really need that says that if you take the cosine of twice an angle, you can just relate it in terms of the angle itself. So we can relate cosine of 72 to cosine of 36. I took that relationship we found and I put in that double angle formula here, and we see cosine of 36 on both sides, but it's squared over here, which really means we have a quadratic equation. Once we solve that using the quadratic formula, we know exactly what cosine of 36 is, cool, square root of 5, and then we can use that original box equation to figure out what cosine of 72 is, now that we know what that is. And I love that it's basically the same, there's just a minus sign. That means we found all 5 x coordinates, so I filled them in, and to find the y coordinates, well, we're on the unit circle, so we can use the fact that sine squared plus cosine squared gives us 1, so if we know the cosine, we can figure out the sine. Here's an example of one of the calculations I did down here. Notice it's square roots of square root. So that's how we got all these numbers in this crazy picture. And because we're just doing square roots of square roots, that actually guarantees that we can construct this with a ruler and a compass, which I think is pretty nice.